Hey guys, today we are going to talk about solving linear systems by graphing. A system of equation consists of two or more equations with the same variables. So, in our examples, we're only going to have two equations with two different variables. And the solution will be the system of equation that satisfies both. So, both would typically be the intersection of the two lines when we have two variables. So there would be one solution in that point. There would be no solution if the lines don't intersect because they're parallel. And there would be infinite solutions if the lines are actually the same. They're right on top of each other, so every point would overlap or be an intersection. So those are our three possible solutions. Okay, so how do we do this? Okay, we actually graph both equations in the same coordinate plane, and to simplify graphing, we write the equations in slope-intercept form first. We can estimate the coordinates of the point of the intersection and then check the coordinates algebraically by substituting into each equation. Okay, so what that means, let's look at this first example. Okay, our first example is actually pretty easy because if you notice, both equations are in slope-intercept form, meaning they're easy to graph from. So for the first one, y equals x plus 1, we start at a y-intersect of 1, and our slope is 1, so rise 1 over 1. So our line would look like this. Okay, when we are solving by graphing, it's highly recommended that you have a ruler to make sure your lines are very straight. So you need to be really, really straight with these. Okay, now the second line that we're going to do is going to be, if you look at this, y is equal to negative x plus 3. So our y-intersect, we start at 3. There's 1, 2, 3. And our slope is negative 1, so we're going to go down 1 and over, down 1 and over. Okay, so there's our second line. Okay, so we noticed that our two lines intersected. The point that they intersected at is an ordered pair. Okay, in this case, your x would be 1 and your y would be 2. Okay, so it's just this ordered pair right here. With a system of equations, sometimes you're going to see this funny little bracket around them. That just means a system of equations. Okay, don't get fooled by the little notation. And once you do get your ordered pair, that's the solution, but it's really convenient to do a check step. Okay, and you can do the check step just by plugging it in. So y equals x plus 1 would actually be our y is 2 equals our x is 1 plus 1. Does that work? Well, 2 is equal to 1 plus 1. That is true, and we do it for both. Okay, the second equation, y equals negative x plus 3. So in this case, our y is 2. Is that equal to negative 1 plus 3? Yes, it is. So it works for both. We know that that's the solution. Okay, so let's try a few more here. Okay, our y-intersect here is 4 for the first one. 1, 2, 3, 4. And this is good practice just for graphing equations. Our slope is positive 1, so we've got a line with the slope of positive 1 right here. Okay, so there's our first one. The second one, we started y-intersect of 5. 1, 2, 3, 4, 5. In this case, our slope is positive 2, so we go up 2 over 1, or we could go down 2 and over 1, down 2 and over 1. Okay, so when we draw the line right here, we see, whoops, it's a little bit off, but we actually crossed at negative 1, 1, 2, 3. So negative 1 and 3 would be our solution, okay? And definitely check your answer on Desmos. In Desmos, you can just type these both in, okay? And you can see the lines, and you can zoom in, and you can see the point that they intersect at. So, but don't use Desmos to solve these. Use it to check. Make sure you know how to do it by hand. So to check this one, I'm going to take my y, which is 3, and my x is negative 1 plus 4. Well, that one works. Now I'm plugging in my y is 3 equals 2 times negative 1 plus 5. That's a negative 2 plus 5. That is equal to 3. So that works. Okay. So we are not always going to be in slope-intercept form. Okay. So if you look at example number 3, we're going to have to bring the x to the other side, and we get a negative x plus 5. Okay. 1, 2, 3, 4, 5, and our slope is negative 1. Okay, we draw a line. Don't forget, when you're drawing your line, put arrows on the ends. Okay, it is a line. All right, and this one, y is equal to negative 2x plus 8. So 5, 6, 7, 8. Now our slope is negative 2, so we're going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. There's our intersecting point right there. Okay, it's at 1, 2, 3, 2. Okay, I'm going to finish making this. Draw my line. Okay, we can see we crossed at 3, 2. That's our answer, because our answer isn't just the graphs, guys. You've got to make sure you show me the point of the ordered pair where they intersect. And remember, an ordered pair has parentheses. It's your x, open parentheses, your x value, comma, your y value, close parentheses. That's the solution. Okay, so, and then I use it to do my check step. I plug it back in. My x is 3 plus 2. Does that equal 5? Yep. And I need to do it for both. So 2 times 3 is 6. 6 plus my y is 2. 6 plus 2 equals 8. Yep, it worked for both of them. Okay, so at any point, actually right now, I suggested if you just pause the video and then you go forward all the way and stop at 9 and 10. Okay, we're going to do 9 and 10 together. But you can pause the video right here and then play it, and I'll show you the answers. Okay, so we'll pause. Okay, continuing on. So for 3, I should have had an answer of 3, 2. If you went ahead and did 4, you should have had 4, negative 3. And if at any point you want to pause the video and check it, you can. All right. Number 5, in slope-intercept form, the two equations are listed there, and we've got 3, 6 is the solution. Okay, number 6, the solution is 2, negative 3. Number 7, the solution is negative 3, negative 5. And number 8, the solution is negative 1, negative 1. Now with all of these, the detailed answer key is available on the class website. So go through it. You can check it by taking any of these values and plugging them back in. So I take this and plug it back into both of those equations. So to do the check step here, I would say 2 times negative 1 plus a negative 1, does that equal negative 3? Negative 2 minus 1 does equal negative 3. So I know the first one works. And then I do it for the second one, negative 6 times negative 1 plus 3 times negative 1. Does that equal 3? This would be 6 minus 3, and that does indeed equal 3. So you can do the check step for each one and verify that they work, and also please put them into Desmos and check using your calculator tool. Okay, so number 9 is a little bit different. Okay, so when we do 9, we've got y is 2x plus 3. So again, in slope-intercept form, that's already there for you. So you start at your y-intercept, 1, 2, 3. And your slope is going to be a positive 2. Okay, so it's going to look like this. Okay, now the second equation, when I put it into slope-intercept form, we've got our 4x minus 8. When we divide by 2, we get y is equal to 2x minus 4. Okay, so 1, 2, 3, 4. And again, my slope is 2. Okay, so if you notice, two lines have the same slope. They are parallel, and parallel lines actually never cross. So this would be a situation where we have no solution. Okay, they're never going to intersect. All right, number 10, when you do that and put it in slope-intercept form, you're going to end up with, we've got a negative y equals negative 3x minus 3, or y is equal to 3x plus 3. Okay, so y equals, we start at the y-intercept of 1, 2, 3. Our slope is 3. Okay, so it should look like 1, 2, 3 over 1. So there's our slope. Our line. Okay, now the next one, okay, when I put it in slope-intercept form, negative 2y is equal to negative 6x minus 6. And divide by negative 2, we're going to have y is equal to 3x plus 3. Notice, same equation, same line, so the line would be right on top of it. So every single point on that line would be a solution. So therefore, we have an infinite number of points on the line, so we actually have an infinite solutions. Okay, no solution, infinite solutions. Okay, so the next type of question says a solution to a system of equation is the ordered pair that satisfies both equations. So it's like doing the check step. Number 11 says if 0, negative 2 is 0, negative 2 a solution to the following systems of equations, all we have to do is plug in for our x and our y, and we get 0 minus 2 times our y is negative 2. Does that equal 4? Let's see, we've got 0 plus 4 equals 4. Yep, that one works. Okay, and now the next one, we've got a negative 2 minus 0. Does that equal negative 2? Yep, that one works. So we know that it satisfies both equations, so that would be a yes. Okay, number 12 is 2, 6, a solution to the following systems. And remember, you can actually see systems with the little brackets like that. Don't let that mess you up if you ever see it. It means the same thing. You're just looking at the two equations. All right, so for y is 6 equals 3 times 2 minus 3. Okay, when we do that, we've got 6 equals 3 minus 6 minus 3. Oops, that would be a 6 minus 3. Okay, and in that case, does 6 equals 3? No. So it's not equal to 3, so that would be a no. As soon as you get one situation where it's no, then the whole thing's no. But we can plug in for the second one. 6 is equal to 2 times 2. That one's also a no, but it doesn't need to be no for both. It needs to be true or yes for both for it to be true. So as soon as you get a no, you can stop. Okay, so looking at the graph for 13, it says, what is the solution to the following systems of equations? Now, some students get really complicated. They figure out the equations of both lines. They plug it in. You don't need to. All you have to do is look at this. All right, it's wondering what the solution is. The solution is right there. It's the intersecting point. So the solution is an ordered pair, and the ordered pair is 1, 3. That's it. That's all you had to do for that one. Okay, so I want you to go ahead and do the practice problems, compare them to the answer key, and the homework should be very similar. Hope this helped.